How many times have you heard of a bit of tech and your first thought was, what the heck is that? Welcome to Foxy's Lab. My name is Foxy and I aim to help you answer that very question. Go grab a coffee, I'll get one too, and then we can get into it. Message Queue Telemetry Transport, or MQTT to its friends, is a lightweight messaging protocol for sending tiny bits of data between devices. Think of it like a group chat for machines. You have a central host called a broker. Devices then connect to that broker and either publish messages to name topics, or they can just subscribe to topics to receive those messages if they're a bit shy. No one is messaging each other directly. Everyone's just hanging out in rooms with the topics that they are interested in and grabbing just the bits that they care about. That's it. That's the whole model. Pub, sub, publish, and subscribe. 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 You can stop watching now if you like. Please don't though, I need the view time and there is more to learn, but if you just wanted the overview, that was it. Still here?
Nerd alert!
Here's a quick origin story. MQTT was created in the late 90s by Andy Stanford Clark and Alan Nipper to move data from oil pipelines over unreliable, low bandwidth satellite links. It had to be cheap on data, needed to be tolerant of flaky connections, but still simple enough to run on tiny low-powered devices, sometimes even battery-powered ones. I remember battery-powered devices in the 90s and they were rubbish.
I'm old, Gandalf.
It stuck around because those constraints map perfectly to the modern world of sensors, smart homes, cars, and anything that talks over a potentially dodgy network. These days, it's a fully open standard with multiple implementations and is used worldwide by industries, the military, data companies, and smart home enthusiasts like me. As it's an open standard, it's also completely free. You can host MQTT brokers on your own server or use many of the cloud-based solutions such as HiveMQ and EMQX. Like everything in the tech industry, MQTT has a ton of often confusing sounding terminology attached to it. I've already used a few of them in this video, so let's break the main ones down. A broker is the message hub. It's the chat room basically. Popular ones are Mosquito, EMQX and HiveMQ. You can run them locally on a Raspberry Pi or any home server solution, or run them in the cloud. As mentioned earlier, HiveMQ and EMQX also offer their own software as a service platform. A client is anything that connects to the broker. These are participants in the chat room. This could be the temperature sensor, a phone app, a back-end service, or an automation tool like Home Assistant or Node-RED. If it connects to a broker, it's a client. Clients can publish, subscribe, or both. A message is a tiny payload, often either a simple string or a JSON object. MQTT doesn't actually care what you send, provided it can be represented as text-based data. A topic is a string path which groups a set of messages. Think of it like a directory structure on your computer. For example, home, kitchen, temp would be a sensible topic to use for a temperature sensor in your smart home's kitchen. Home would be the root topic. Kitchen would group all of the messages coming from the kitchen, and temp would be the actual temperature values coming from your sensor. Okay, QoS. Now we're getting slightly into the deeper stuff. Don't worry though, it's all still pretty straightforward. QoS, or quality of service, is in a nutshell the effort that MQTT will make to ensure that your message is sent. Let's leave the chat room analogy aside and swap over to using the postal service as an example. QoS 0 is basically fire and forget. This is like sending something with a second-class stamp. The broker sends the message and then it stops thinking about it. Doesn't care if the message reaches its destination, its job's done. It will never attempt a second delivery of the message. QoS 1 is like using first-class signed delivery. The MQTT broker expects confirmation that the message was received and will try again to send the message if the message fails to send. QoS 2 is basically your guaranteed next day delivery, but with a twist. It will still only attempt to deliver a message once, but it's very thorough in its checks before sending the message. It will confirm you are home and ready to receive. It will then send the message and then check you have received it. And then I'll send another message congratulating everyone on a job well done.
Good job, everyone. Congratulations.
Actually, that's a bit of an oversimplification to make explaining it easier on this video, but if you understand the analogy, it means you get the gist. I'll put a link to a more technical explainer in the description. As you might imagine, each QoS level steps up the reliability of the message, but also the bandwidth required. QoS 0 is fine for most low priority needs, like our temp sense, for example, earlier. It doesn't really matter if one message gets lost every now and again. QoS 1 and 2 are perfect for more mission critical operations where you need a guarantee that every single message definitely made it to its destination. In a smart home, this is useful for button presses, for example, or vital sensor data in an industrial or military application. Wildcards are a very handy way of saying, I'm easy, order me anything from the menu, or topic in this case. To reuse our example from earlier, if we set our topic to home/kitchen/hash, That would tell the broker that we want to subscribe to every message that gets sent to the kitchen topic. We can also use the plus symbol to match all parent topics. So we could use the topic home/plus/temp if we wanted to subscribe to every single temperature sensor in our entire house. Very handy for data aggregation. Message retention, or retained messages, are ways for MQTT to store a snapshot of the message history. Without retention, the broker will immediately forget the last message as soon as it's sent out. If you enable retention on a topic, then it will store the last message sent in memory. So even if a new client subscribes to that topic, it will immediately know the last value that it sent out. A will message is the dramatically named message for the message a broker will publish if a client unexpectedly drops off the network. Think of it as the broker saying,
"I will avenge you."
No words to that effect. It's super handy for creating a "this device is offline" message in dashboards or to account for disconnects in automations. Similarly, a birth message is the message a client will send to the broker when it connects. Think of it as saying,
"Hello there."
There's also a close message, which the client sends to the broker to let it know it's just popping off to the shops for a bit. Sessions, or keep alive, creates a persistent session between the client and the broker. These are utterly pointless if you're only ever sending QoS 0 messages, but can be quite handy for QoS 1 and QoS 2, as the broker will queue messages for as long as the session is alive. So when the client comes back from the shops, the broker can say, "Jeff called, by the way, dude, he says you're a prat." That's the main terminology you need. You now know 90% of what matters. If you learn all of this, you are golden. If you want to take away one thing from this, it should be that I don't actually have any friends called Jeff, and I'm sure all Jeffs are lovely. I use MQTT all the time in my smart home. If you're just getting into smart homes, you've probably already ran into issues that devices from different manufacturers often don't like talking to each other and will require their own sodding app. It's not a problem for me in my smart home, as due to a mix of Zigbee to MQTT, Node-RED, and of course MQTT, videos on the other two coming soon, my devices don't actually ever need to talk to each other. Quick example, if I push the Zigbee button on my wall, that wirelessly sends a signal to Zigbee to MQTT on my smart home server. That sends an MQTT message to Node-RED, which responds with,
"I know what that is."
It then sends another MQTT message back to Zigbee to MQTT saying, "That button toggles the office lamp," and Zigbee to MQTT sends a signal to the Zigbee lamp, which turns it on.
Simple.
MQTT is tiny on bandwidth, dead simple to implement, and decouples senders from receivers. Publishers don't care who's listening, and subscribers don't care who produce the data. That makes systems decoupled, which makes them easy to evolve. Add a new service, subscribe to an existing topic, done. It's not a database. If you try to use MQTT as a database,
You're gonna have a bad time.
even with retention, you'll only ever capture the last historical state. It can easily connect to a database though. My recent video about using MQTT with Node-RED and Influx gives an example on how to connect an MQTT topic to a time series database. So check that one out if you're interested. It's not a message streaming platform either. If you want to queue up a bunch of messages, then again, this isn't really what it's for. It has no real back pressure capabilities, so you'll still need a purpose-built solution for this, like RabbitMQ or Kafka. Despite message queue being in the name, it really is mostly focused on the telemetry transport side of things. MQTT is a pretty simple topic, but that's not to say it's without its gotchas. You can avoid these by sticking to some simple rules. Rule 1. Avoid messy topic names. Pick a scheme and stick to it. Large to small, stable nouns, clear units. So the earlier example of home, kitchen, temp starts large, the site name, then goes a bit smaller, the room name, and then temp is smaller still and declares the unit we are measuring. Sometimes it's not always possible to conform to that pattern exactly, but it's a good rule of thumb. Rule 2. Don't overuse QoS 2. It looks comforting, but it's heavy. Start with QoS 0 and then escalate only if you actually encounter a problem or if you know you're going to need a perfect response every time. Personally, I use QoS 0 everywhere except for actions. So most of my sensors are QoS 0 and then my buttons and present sensors are QoS 1. Sometimes I go to 2 if I find reliability issues, but 0 and 1 are my usual go-tos. Rule 3, use retention. It's usually worthwhile having retention on, and in fact a few clients either have it enabled by default or don't giving you an option not to use it. A retained message means that any new client subscribing to a topic will instantly know the last message sent, which avoids issues with data mismatching or typing errors. Rule 4, make sure you use authentication. If you're just running MQTT locally in like a testing lab, then no auth is fine for learning, but anything actually on the network that matters should use usernames and passwords. Never expose an open broker to the internet. Even authentication can be cracked, so it's usually worth putting it behind something like Tailscale or a VPN. Videos on those will probably be made at some point as well, and adding authentication. Okay, so that was MQTT. So now when your mates at the pub talk about MQTT brokers, which happens all the time, right? You can now confidently join in and show them you know your stuff. Or you can ace that meeting or whatever. If you found this useful, please hit the like button and tell your mates down the pub about me. You could also start practicing your MQTT skills by pretending I'm a topic and subscribing to me. I'm new to YouTube, but I plan to produce lots of videos about smart homes, IoT, and just generally nerdy tech stuff. So if that tickles your fancy, the button's right there below the video. Go on, you know you want to. Ta-ra!